All right. Method for big data management in EPC firms during the engineering phase. My name is Joe Said, and I worked in Politecnico di Milano and Tecnomont company there. So, quick agenda. I'll give you a background of what I did, a methodology of what we created, a case study, and some conclusions. Background is pretty simple. Everybody here has been talking about BIM all day. We have standards, we have modeling software, we have review software, and all this data creates a lot of data that isn't monitored usually in big companies. So what's the next step is to use big data management technology such as Power BI to solve it. Just want to say that Power BI is not the only way that this can be used. There's many different softwares that can be used. And this methodology can be applied to any of these. So the methodology quickly is an 8-step process. We explore the data, exploration, which understands the data, then mapping, and then where we check the requirements by the end user, and we map the data points to the solutions. We extract the data based on the ones we're going to use. We format the data, which is to verify the data is suitable and usable for the visualizations. We create our visualizations, and then we try to automate this whole process. And then once we're done, we usually start with a small sample size. We do testing, which gives potential to users to give feedback and check bugs, and then we reiterate. Throughout this methodology was created through a reiterative process, because once I went to that company, we started working right away, and the methodology was built through it. Going through the methodology again a little bit more closely, exploration gives you an idea of what the data is like. So first you want to know where the data is stored, how much data you have, the variety, how much it changes, and how fast you need to refresh. The types of data, usually just standard. So if you have a number, you got to make sure that you're going to multiply it by number, not by something that might have like 100 M for 100 million. And then some data analysis. You want to know exactly what you're going to do. This helps user understand what they're going to do and talk to the client before starting getting into the data so you don't get confused. Mapping, again, like I said, it's taking the sources. So which column is going to give you which check, which first you can either do a parallel plot or an explanatory table, and either is useful. The plot helps you understand how much one column is going to be used and which columns might not be used. Like you can see in source 1, column B won't need to be extracted, and then the table helps you understand what needs to be aligned and matching. Then we have extraction. So it depends on where the data comes from. In the BIM world, you can extract an IFC and have IFC SQL to have a database of the IFC. You can extract the schedules as a database. For example, you can have a database simply as a CSV or something that might be populated by your users. And then from the CDE, the common data environment, you might extract the database of folder names, file names. And you can have a streamlined data flow. This is kind of the next step. Which connects data or like a common data environment like Autodesk Construction Cloud directly to something like Power BI. Then you have to know where your folder is going to be located for extracting. You want a private folder or a shared folder. Private folder, obviously, you need to share the location of the folder to end users. Shared folder will be available to whoever's in your company. Okay, and then formatting. Formatting is very important. It's we created 3 different ways to format: cleaning, creating, or linking data. Cleaning is like fixing text. As you can see, the project name, you can extract just the number. You can fix the number. If the weight you want it all in pounds or you want it all in kilograms, you can change that. If there's an error, you can remove it. And if there's some filtering of the project, you want only project 1, 2, 3. And finally, if there's something that's out of the range, like the weight of this element can be more than 20 kilograms, you remove it as well. Creating new data is usually based on other data. Addition and transformation are pretty similar. You can create new classes or new structures. Conditional format is, and that's the same with conditional, and then combination is when you add 2 columns together, like project and area. You can also split them. And yeah, this is where you can transform some data. And then linking data is an important step, since sometimes you have multiple data sources. This is an example from one of the dashboards I created. As you can see, sometimes the ID in one source isn't the same in the other. So it's important to relate the data so that when you come and visualize the data, or say that you want to find this email for this person, you'd make sure that you're picking the right ID. Without a proper visualization, you might have the most important data, but it won't be beneficial to the end user. Usually, the way I did in my dashboards, I'd want a dashboard title across all the entire dashboard, every page. You'd want some navigation, company logo, usually a page title that describes what the person's looking at. Power BI has its own filters on the right side of the page usually, but I created the filters inside and hid the filter pane because I realized that users prefer to see the filter right there and create it, and it gives me the ability to control what they create. And then we had a sub navigation panel in case so we have like discipline and type. Then we have charts. Again, there's many charts. There's more information in my thesis of the type of charts and which ones you can use. Make sure the spacing is clear. And then finally, the date of last update is usually helpful so the person knows what they're looking at. Automation starts with the steps required for refreshing dashboards. So there's 3 steps for refreshing a dashboard. Usually you export the data again from the source, you refresh the dashboard visuals, and you publish dashboards online. Depending on how many of these steps you take, depends on how much the level of automation is, whether it's manual, semi-automated, or automated. We'll explain that also on the dashboards as we go. Finally, testing and reiteration. It's very important to test. So first, I start with a small sample size of data so I can create the dashboard quickly and give it to the end user or a few of the end users so that they can tell me what's wrong with it, what they want to see, any bugs that they might find, and then add larger data sources later. And again, like I said in the beginning, reiteration is part of the process. You're always going to have to reiterate because most dashboards are live and they get updated all the time. This research was okay. Now into the case study. The research was commissioned by Mairi Technomont. Mairi leads a technology and engineering group that develops and implements innovative solutions to enable energy transition. Within that, there's Technomont, which is Mairi's large-scale EPC contractor, and then within that, there's many departments. One of which is the civil, which is where I worked, and there was 3 disciplines within civil: concrete, steel, and underground. And I created 4 quality dashboards and 1 quantity dashboard. I'll explain more of those now later. First, I'll explain how data is created and stored in the project, and then how these dashboards or where these dashboards get data from. So obviously we have modeling softwares like Revit or Tekla or other softwares. I'm just explaining a little bit. And then some of them get updated into a common data environment like the Autodesk 360 or Autodesk Construction Cloud. And using a cloud-based development like Forge or Platform, the company created a CMD, which is a civil master data, or CIL, which is a civil item list, where they have a storage of all their data, and it's manually updated by discipline leaders based on the 2D drawings. So this is 2D drawings based with a 3D viewer, but manually updated, not based on BIM element sizes. Then we have a review software that we all know, like Navisworks or Solibri, where data can be taken when you want to merge all the models together. And you have a database storage such as Excel or SharePoint, where you can export schedules, you can export quantities, and usually that goes straight to the construction database using Aveva or MileMate. It's not specifically a construction database, but this is the database that the construction site uses based on the model elements in the BIM world. Now I'll explain where the data comes for each dashboard. So quality one focuses on folders. It focuses on where the files are located in the common data environment, whether it's in transfer, work in progress, consumed, or shared. And it compares them with the review software, the federated model that has all the files. The next one, quality 2, checks elements. So each element needs to be checked for tagging type, tagging convention, whether it's named correctly. And this is quality 2. It takes it from the federated model. Quality 3 compares the two dashboards or 2 databases, like I explained earlier. The one that's company-based, manually updated, and the one that's from the BIM world, I guess, that takes the 3D models and gives you quantities. So it makes sure that all the main items are within both of them and that the quantities align. And finally, quality 4 takes directly from the common data environment. This is the one that uses Autodesk data connector, the ACC data connector, to check squad checks. So a squad check is when, for example, piping department wants to make sure everyone checks the drawings before they start sending it out for signing and for construction. So they'd send out a squad check. Everyone needs to sign off like, yeah, this is good. But usually there's no follow up on who's doing well, who's in a hurry, who's not doing it quick enough. So this dashboard checks that. And then quantity one is just a historic background of the quantities of the projects and how projects are progressing, the current projects. Okay, going into each one again, quality. These all use the same methodology that I spoke of earlier. I'll just explain it again, the objective and what it looks like. So quality one is used to ensure models are stored in the correct location in the common data environment and the federated model. Again, like I said, the first sheet, you can see the alignment between shared folders and WIP on the left, shared collab and transfer folders on WIP, which folders aren't in the right location, and it tells. So a BIM manager can go to the modelers and be like, hey, this folder's in the wrong location. And then on the right, you can see the difference between the transfer folder and the federated model because they need to align also. All the files inside that, all the models inside that need to be the same. And you can filter by project. The next sheet is if it's outdated, usually in the WIP model, WIP is work in progress. If it's in the WIP folder, it needs to be updated regularly. And if it's in the transfer folder, it needs to have an updated WIP. So if it's 10 days late, it needs to be updated. And then again, this was updated in August, so obviously the dates are a little bit off. But again, you can check by each project and check which ones are late and which ones aren't. Duplicates, pretty straightforward. You don't want any duplicates in your folders. And then this is errors. Any files that aren't Revit or IFC need to be taken out. This was semi-automated because you'd need to re-export the files every time, but you can update the refresh automatically, but you need to export from the federated model and you need to export from BIM 360. Quality 2 was the one that required to match company standards for elements properties, used to show modelers errors and how to fix them. So kind of like any standard, our company, the company that I worked for, had their specific standards. So it'll tell you how many models are completely 100% accurate and some have incorrect models and which elements are incorrect in which model based again on project and discipline. You can go a little bit deeper, which models have which problems. Again, by project and discipline, it shows you, oh, this is the top 5 errors. What's the most error in this model? What needs to be fixed? So some things might not be standard and they need to go back. And of course, we have all that in the back end. And then this elements sheet, you can export it because we found that the modelers weren't using the dashboard that much. They were more used to an Excel sheet. So you can export this with the highlighting and send it back to them so they can check which ones they're late on. Hopefully our goal is that, and then they come in, write their model name that they're working on and check which elements have errors. Again, all this is done by formatting in the background on which elements are incorrect. Quality 3, which makes sure items from models are loaded in the company database and that quantities match the construction quantities. So this is completely manual. I'm sorry, I didn't say this is semi-automated because you still have to export everything from the federated model. That's quality 2. Quality 3 was completely manual because you need to export, you need to update the visuals, and you need to republish every time just because you have 2 different sources and that isn't useful for us right now. Okay. And so this is, you check by tags whether they're loaded, pending, or delayed. This is based on whether the element in the CMD is ready for construction or not. If it's ready for review, it can be in the pending phase. And there's a 10-day leeway for it to be delayed. You can check it by project, by subdiscipline, and then percentages. This is kind of an overview. This is by specific item tags. So again, this is, as you can see in the top navigation, AX means all of them. For each one, AA, AI, and AQ, steel, concrete, steel, and underground, there's more sheets, but I'm only going to explain the main one. Gives you more in detail here, and then this is the quantity matching between the Aveva and the CMD. And finally, this is a complete database so that someone doesn't have to go open 2 sheets, one on Excel and one on Power BI to read which elements are missing and where there might be. Quality 4, which was kind of great, highlights missing reviews and helps identify the department's performance and speed and squad checks. It's completely automated since the data is directly exported from ACC into Power BI. This one just checks, like I said, which department might be late on squad checks, which department might not be ready for a squad check, or which department is still missing. So this is the overview of how many squad checks are open, how many are closed. And then the next sheet is a detailed. You can, as a user, you can go in, check your ID, check who's missing, check by the reviewer name. You can check your name. You can check by department. So it kind of helps everyone get on the same page on who's late, who's not, who needs to fix it, instead of going through BIM 360 and opening each review on its own. Finally, the quantities gives a historical background and ongoing progress of material use and model development from the CMD and the CIL. So again, quantities, foundation, concrete elevation, all that. And you have in the filter up here, you have AAAI, which is concrete, or APAQ, which is underground and paving. This is a summary of it. This is a size of between different projects to see which project is bigger than others based on tack type. This is the progress. Again, IFC isn't the IFC that we know. It's issue for construction in our company. And then IFR is issue for review. So you know how ready the model is to be built. Quantities per project, by budget, work required, and quantity current estimate. The current estimate, see a historical background on what it was and what it is now. And then this is a trend of any finished project. It shows you every 3 or 4 months they do a new current estimate. So every 3 or 4 months they update that. And you can see starting from when you started in the budget or in the work required, you can see how far you've gotten from it. Finally, we have to store this in 3 folders. Trying to go a little bit faster. Where the dashboards are, where the data sources are, and data reports that are updated weekly. Obviously, the automated ones are updated automatically. Semi-automated need a click or two, and then the manual one needs to be fixed. And then this is part of my conclusions and recommendations. So the methodology is applicable to any software and data structure and types, as long as you're trying to build a data storage system, data management system for BIM. Most of the best dashboards are being used, except for the manual one, Quality 3. And of course, the future recommendations is to find a way to increase automation, especially from something like Navisworks directly into Power BI. If you can automate extracting the data from Navisworks directly into Power BI, that would further develop this. And then developing, that's it. Thank you.